multidisciplinary design project, Group 10, consists of 8 members, 2 from computer engineering and another 6 from computer science. Together, they design a robotic system that can autonomously explore and traverse an unknown area, avoiding obstacles. On top of that, this robot is able to plan and follow the fastest path from point X to point Y. An Android application is developed such that it can control the robot remotely and provides interactive graphic user interface. For testing and prototype purpose, a software simulation is used to demonstrate the algorithm.
Basically, the mobile robot module consists of 2 main functionalities. One is for the sensor data acquisition and another one is for the motor control. So in this module, we'll be using Arduino as the microcontroller to implement these functionalities and logic block. And Arduino is basically a single board microcontroller that makes using electronics in multidisciplinary project more accessible. And we are choosing Arduino because due to this advantage of having a set of I/O ports that are readily connected directly without any more further electronics modifications. So for the first part, for the sensor control, basically we will have 2 front short sensors used to determine obstacles at the front, one at the left, robot's left, to determine the space between the boundary and the robot, and lastly have the last sensors to determine for the long range mapping and then as well as for the long range of obstacles. And secondly, for the motor control, basically we will be using dead reckoning in controlling the robot, which means that they are basically having 2 wheels driving independently of each other. And to make it drive straight, basically we just have to apply both wheels to run at the same speed to the front. So for turning wise, we'll be using a point turn system, which means that we will just apply 2 opposite force to these 2 wheels to make it spin on its own position.
Raspberry Pi is a credit card-sized CPU running on ARM processor that's capable of performing tasks close to desktop, such as word processing, spreadsheet, and playing games. So basically, in our project setup, Raspberry Pi is used as a middleman or a gateway to coordinate the flow of communication between Nexus 7, laptop, and Arduino. It should be able to accept incoming messages from one of the components and forward it out to the other component. Wi-Fi communication channel will be used between Raspberry Pi and the laptop, while USB-C will be used between Arduino and Raspberry Pi.
For our Bluetooth, we use Bluetooth packages that is initially not installed on the Raspberry Pi. Therefore, we need to install these packages on the Raspberry Pi in order to make it work with the Python programming language. And once we have installed these packages, we can test the communication with the Android devices. The purpose of the Bluetooth communication from the Raspberry Pi to Android is to send and receive message between these two devices. For example, the obstacle location and the current location of the robot. And also the message for testing purpose.
Nexus 7 tablet is an Android device and we are using it as the wireless remote controller for the team operating system. How to make the application works? First thing to do is set up the Bluetooth communication between the Nexus 7 and Raspberry Pi. After it has connected, then it will display as a feedback to the user that it has connected message. Second thing to do is you can control the robot by using the navigation button provided in the application itself. You can move forward, backward, left and right. And also for the competition, the start button to start the robot from start to go state, and then return button to return from go to start.
I'll be touching on the map traverser and the path traverser. So how does the mapping works? Basically, we have different phases. During the exploration phase, the robot will actually traverse along the circumference of the arena to actually mark out any obstacles that are on the way. So we will make use of 4 different sensors: the front left, front right, left, and the right. So we'll be using the left sensor to actually do the path recovery when it hits the obstacle. So when the robot is actually moving along the x-axis, when it senses any obstacle, it will actually avoid the obstacle, and at the same time, it will actually mark any obstacles that are seen within the range. As it travels along the circumference, it will be able to cover obstacles that are at the inner areas of the arena, because the right sensor is actually pointing towards the inside of the arena. So with that, we'll be able to actually plot out the obstacles into a form of an array and set it to pi. Okay, so with the mapping and plotting done, how is the robot going to move from the goal point to the start point? Basically, we are using A-star algorithm.
The Yr2013 is the idea to implement the A-star algorithm. It displays all the obstacles and the source path of the robot from the goal point back to start point.
Our greatest achievement during the arena is that we are the first team to be able to complete the arena in week 8, and during that time, we also managed to clock our best timing. After going through this module, we believe that not only have we acquired knowledge to create a robot, but we have also learned to make new friends and bond together through thick and thin, overcoming obstacles together.